Hello, friends. Welcome to our fourth Coachella Valley Wildflower Festival Wildflower Wednesday. This week's presentation is brought to you by the City of Palm Desert, the Agua Caliente Band of Cahuilla Indians, and Friends of the Desert Mountains. Friends of the Desert Mountains is actually who puts on the festival. And let me tell you, the festival is chugging right along. Our 30 by 30 by 30 fitness fundraising challenge participants have just over a week left to complete their 30 miles. Some have already done it. Some of us really need to get out there and do more of it. And if we do, we might get a chance to see the wildflowers. They are beginning to pop throughout the valley. Tracker told me where to find them. If you want to know, you should ask us at Friends of the Desert Mountains. And hey, shh, nobody knows this, but our silent auction goes live tomorrow at desertmountains.org CVWF. Desertmountains.org CVWF. And our silent auction goes live tomorrow morning. It lasts for just 5 days. So do not delay. Go check out the fun things that we have. Our donors have been extra generous this year, and we're super happy with the selection of prizes that we have. We had adventures and art and all kinds of great stuff. So go check it out, desertmountains.org CVWF. Now, tonight, we are going to take a look at the sun. No, we're not going to stare at the sun. That's a silly thing to do. That's reserved for flowers. We're humans. We're going to take a thoughtful, humanistic approach to checking out solar astronomy. That's right. Now, our volunteer star guides are John Frazier of Desert Hot Springs and Bruce Gottlieb of Palm Desert. Now, I say star not only because these gentlemen are our stars tonight, but they have also helped Friends of the Desert Mountains put on many, many stargazing parties up at the Santa Rosa and San Jacinto Mountains National Monument Visitor Center. Now, we all know the Visitor Center is currently closed due to COVID concerns. We want everybody to stay safe. But no doubt when we are able to be together again, I just know that John and Bruce are going to be there to help us out. In the meantime, we've decided to go virtual. We have to do that. We do. So let me get it all set up here and we'll hear what the guys have to say about their favorite star, the sun. All righty, folks. All right, John, take it away.
You have tuned in to our little talk here on the sun. Welcome, and my name is John. I have with me Bruce Gottlieb, who's going to present some interesting facts and pictures a little bit later. But this is a very basic run through of our closest star, which is the sun. The sun is, of course, the center of our solar system, and when it formed as a protoplanetary, as part of the protoplanetary system, it formed and reached a certain collected, all it collected hydrogen, and as it collected hydrogen, it became more massive, more dense, and the pressure and temperatures in the very core of the sun increased to a point where all of a sudden it ignited in a fusion reaction. And it is basically what you're looking at here is a diagram or a picture of a fusion reactor. And by that I mean that hydrogen, which makes up most of the sun, about 98% or so, and a little bit of helium and a tiny bit of other elements. The hydrogen is slammed together. The atoms of hydrogen are And with that reaction, it's going on so intensely in the very core of the sun that it produces just incredibly large amounts of energy. And that energy is represented all across the spectrum of electromagnetic radiation. It sends out X-rays, it sends out gamma rays, it sends out white light, of course, which is made up of colors. It sends out radio waves, and it sends out infrared, and it sends out all these different different types of radiation, and it is it's easy to sort of not think about the sun. And we take it sort of by granted because it's always up there during the day, and we just don't think too much about it, except of course when you get a sunburn. So make sure you wear your sunscreen, okay, especially in the desert or on a mountaintop where the atmosphere is thin. What we are looking at right here again is a hydrogen alpha picture of the sun. It's a narrow band photograph, which means it's only taken, the photograph is taken only in the hydrogen region of the spectrum, a very tiny portion of the spectrum.
That's what I was going to ask you, how you took a picture of the sun.
It's taken through filters, special filters that allow hydrogen alpha wavelength to come through and blocks everything else. And so what you see here is what is called the Chromosphere. This is a very thin portion around the sun that contains what are called speculation or spiculacies. This kind of patchwork pattern here. And these little guys along the edge, we call these little lips along the edge. Those are spicules, and that's the normal pushing out of the energy that the sun undergoes. Then you have these guys here. These are prominences. You can see these prominences around here. And as you can see, a lot of these prominences are as big or bigger than our own Earth. This is a size comparison. So if you want to think about size, you could fit 1.3 million Earths inside bag as big as the sun.
Because that's easy to think about.
And Jupiter, and the next largest member of our solar system is Jupiter, which is only 1,300 times the size of Earth. It's a very big planet, but in relationship to the sun, it's still pretty small. The sun contains, by mass, it contains about 98 or so percent of the mass of the entire solar system. So that gives you an idea of just how big our sun is.
Does the sun have gravity?
It has intense gravity because of the size that it is. Its mass dictates, the mass of an object in space dictates how intense the gravity is.
Even when it's a gaseous thing like this?
Well, yes, absolutely, because as you go towards the core, things are packed tighter and tighter and tighter. So you have millions upon millions of times more density in the core than you do in any other planet. And the temperatures reach into the believe it reaches into the millions of billions. I can't think of it right now, but it's that temperature and pressure that allows the fusion reaction to occur. Now the sun is as old as the solar system, which is about 4.7 billion years old, and it is classified as a type G yellow dwarf, and which tells you that it's not the biggest. It's not the biggest member or biggest star in the universe. There are stars that are hundreds, thousands, and millions times larger than the sun, which is one of the things. The immensity of space, and the numbers involved, is one thing that draws me to the science of astronomy. So over on the right hand side here, this is a representation. This is a photograph of the sun through white light filter, which means that it allows white light that blocks any harmful radiation from coming through.
Okay.
And it's very easy. It's very easy with a white light filter to see the sunspots. Now, this photograph was made some time ago when the sun was very active, and so you have a lot of sunspots. Today, the sun is not very active. It's actually towards the bottom of what they believe to be 11-year minimum, but it's on its way back up, and the scientists believe that as time goes on, it'll become more and more active, producing more and more sunspots from which prominences and flares erupt. And these are along magnetic lines of force. This is, if you've ever taken a bar magnet, placed it underneath a piece of paper and spread iron filings, you see the magnetic lines of force. Do that at home or do it in school if you can, because it's kind of fascinating. But it's similar to what happens here. The magnetic lines of force, since there's there's an outpushing of energy and hydrogen plasma, which is hydrogen stripped of its electrons. And so you have it coming up on one side and then going back down on the other side. And it takes various shapes.
Is this similar to when we see auroras on our planet? Is that kind of the same interaction is happening?
Well, it's a little bit different. The solar winds, actually, you'll be able to see the corona. You can't see the corona here, but you will during Bruce's presentation.
Okay.
The surface of the sun here this is the photosphere, called the photosphere. This is this is a relatively quiescent looking thing, but certainly a lot of activity. But it's from these sunspots that you have these eruptions along magnetic lines of force. It's as if the magnetic lines have snapped and allowed the release of energy and plasma. And they take on various forms, they take on various intensities. You'll have the speculation, which is little minor things. You have flares, and then you have prominences, and then you have large flares, which actually might, if pointed towards Earth, might reach out in the solar wind, which reaches out to the edge of our solar system, and it will travel around our magnetic sphere of protection around the Earth, and it interacts with atoms in our atmosphere, causing the auroras on both north and south poles.
Okay, so it does come from there. It comes from the sun.
Yeah,
Okay, good.
it is caused by the solar wind of the sun. So one thing that I wanted to mention was that the core, which is only about 20% of the size of the entire sphere of the sun, is producing this immense amount of radiation and intense heat and radiation, which flows outwards. But then you have the gravity that draws things inwards. And at this point, there's a balance between the radiation and the gravity. And this has gone on for, like I said, about 4.7 billion years. And it's supposed to continue on for 3, 4, 5 billion years more.
Good.
And but this is what gives our planet life. This is what is responsible for most life on Earth. There are organisms that can live without photosynthesis, but the great part of our Earth is based on photosynthesis and the evolution of oxygen on our planet.
So those other stars that are bigger and whatever, they're not necessarily stable enough to do what our star does.
Right. This is a Hertzsprung-Russell diagram, and this shows you the relationship of different kinds of stars. This is the main sequence right here, and you can see that our little sun, is right there, sort of in the middle, right here. And these stars are less hot, and these stars are more hot than our sun. But then, and then it's during a certain point in the sun's life, there's a birth from clouds of gas and dust. Then there's the life that our sun is in now, and then there's a death where it ultimately runs out of hydrogen fuel. And as it does so, it evolves into a red giant or a red supergiant. Antares and Betelgeuse are both super red giants, and these are towards the end of their life, where eventually they will go supernova and form other really amazing things we call nebulas in our sky. But that's just to give you an idea that not all stars are the same, and they vary. There's an incredible amount of variation between the different stars. You can see a lot of them are quite a bit bigger than our sun, but then there's a lot of them called brown dwarfs that I believe are Bruce can maybe correct me if I'm wrong, but I believe it's the brown dwarfs that are thought to be the most numerous in our solar system, at least from the data that we have today.
And are those like the youngest stars?
No, those are just a whole separate. They never really they formed, but never really got off the ground. As far as they never really got to be the size of our sun.
Got it.
They may have planetary systems, but that's about it. That's a very recent photograph, or a recent photograph of our sun as it is right now, or I think it is. Let me see here.
But you don't see a lot of the flares and the prominences happening.
Yeah, this is from Big Bear Solar Observatory. As you can see, it's March 24th, but not a whole lot of, I don't see flares, very minor stuff here along the edge. There's a little tiny one there, wisps, and possible, there looks like there's some possible sunspots right here, where there's a little bit of activity going on. And then, as you can see, there's a lot of different resources. If you're very interested in learning more about the sun, there's a lot of different resources. Big Bear Solar Observatory, which is very near us. Let's see here. So this is a website, halpha.nso.edu, that has ongoing solar photographs that are updated from various solar observatories around the world. For instance, this is Big Bear that we just looked at. And as you can see, there's a little same thing. There's some stuff going on around the edge. And here, I think that's a sunspot right in there.
Yeah, so when you see it in black and white like this, you get a little more, your eyes can look at it better than that bright orange spot.
You get a little more detail with what we call monochromatic, black and white.
Right.
But then you can see the speculation in the surface here. And this is just the normal sun doing its thing.
And like the moon, do we always see the same side of the sun?
No, the sun does rotate.
Okay.
And that's a good question. I can't. Maybe Bruce can tell us. I cannot for the life of me remember the rotational period of the sun. I don't think it's as long as the Earth, but he might be able to. Bruce, Jan?
Yeah, I think the sun rotates, if I recall, like every maybe 7 to 10 hours. It rotates.
Yeah, that's what I was thinking. Yeah, that's what I was thinking. So it's a little bit slower, but there's a lot of mass there. And even though the solar disk looks spherical, it's not actually. It sort of bulges in the middle because of the rotation and the mass of the whole thing.
Wow.
But anyway, for those who are interested, there's a lot of different resources out there.
Is this generally a good area for doing observation? Do we have good, clean air for?
Not now.
Oh, yeah.
In fact, it rather does suck.
Yeah. I mean, we had a rare blue sky day today for a few weeks, but just in general, the air quality is not good for.
Well, if you can get it on a day that's not up here in Desert Hot Springs where I am, it's just windy as all get out.
Yes.
But there are winds going through. But if you can get it on a day that's not windy, and then also where there's not a lot of dust in the atmosphere, which is blown up by the winds, and if we're not having a wildfire somewhere, astronomy is a science hobby for the optimistic person. I think we hope for good conditions, but we take what we can get. So anyway, I'm hoping that is provides you with just a general rundown of our sun, and maybe Bruce would like to take it away.
Now, hold on a second. Before I let Bruce come in and do his bit, I just want to thank both of you guys again for coming out and doing this for us. You know, people are just hungry to connect, and they're hungry for knowledge. And I know you think that, you know, maybe this is a dry presentation for you, John, but I'm loving it. I think it's great. And you guys are going to love what Bruce has to talk about, which is one of our favorite things, when the sun actually kind of goes away for a little while. That's right. The sun takes a vacation. And Bruce likes to go and see when the sun takes a vacation, I think is pretty much what it boils down to. So, and if you guys want to know more about what he's getting ready to talk about, which is eclipses, he's actually going to tell you when the next one that we can see is going to happen as well. So stay tuned. And here we go with Bruce. Take it away.
Okay, let me.
Hey, Bruce. Welcome.
All right, my name's Bruce Gottlieb. I'm actually president of the Astronomical Society of the Desert, and I am going to give a talk today on about solar eclipses, and in specifics, the total solar eclipse of 2017, which was the last solar eclipse total visible from the United States. It had been 38 years prior to this, then we had our last total solar eclipse that we could see basically from home. Here's the path of the eclipse. It started in Oregon, came off the coast of the Pacific, Washington, Oregon, Idaho, Montana. I actually saw the eclipse in Casper, Wyoming, through Nebraska, the Midwest, and actually off the coast of South Carolina. So this was a phenomenal eclipse, went across the entire United States, which is very rare.
So what time of the day was this?
It was about noon,
Cool.
approximately noon.
Mm.
Now, what happens during an eclipse? Well, we have the sun, and the moon is in between the sun and the earth. And the moon casts its shadow on the earth. Very small shadow, as you can see, this gray area comes basically to a point which can be like 50-mile wide swath on the earth. So you have to be within that 50-mile wide area to see a total eclipse. Now, if you're away but nearby, within probably 1,000 miles, you see a partial eclipse, where some of the sun, like here locally in Palm Springs area, I think we saw about 60% of the sun was covered up, but you don't see the totality, which is when you see the corona.
Right.
Now, you might ask, why don't we have a solar eclipse every time the moon goes around the earth? Because every time it goes around, it's basically going to be in between the sun and the earth at new moon. Well, the orbit of the moon is tilted 5 degrees to the orbit of the earth. And only when the moon is in these two spots, at the node intersecting the ecliptic, or the path of the sun around the earth, can there possibly be a solar eclipse. And of those times, there's not always a total solar eclipse.
Huh.
I attended a convention, AstroCon in Casper, Wyoming, which was phenomenal. I'll go through these a little quickly. The whole town, the whole area was eclipse crazy. This is downtown. They closed off the downtown area. You can see, and I'm a retired pharmacist, and this struck me because it says cowboy scrubs.
Yeah, and they're actually selling scrubs off to the side. I can see it.
And it was a scrub store. That's what their primary market was, scrubs. And they call it cowboy scrubs because, of course, I'm in Wyoming. So here's the Eclipse Festival sign.
Feel the shadow. Can you really feel the shadow?
Actually, you can, and I will show you proof that you can feel the shadow.
Okay.
This was a local bakery, restaurant, breakfast type place, which for some reason says they're open during the eclipse. Now, anyone, if there's a total eclipse going on in your hometown, you don't want to be inside.
No, you want to go see it.
Yeah, because I think they put this because the entire town basically closed down the morning of the eclipse.
Got it. It wasn't because of superstition or anything. They were just...
Oh, yeah, it was just so the employees and everybody could go out and watch.
That's awesome.
Every restaurant you went to had Eclipse souvenirs, Eclipse coffee mugs, books, Eclipse glasses. Now, the one thing about an eclipse is, or anytime you look at the sun, like John had alluded to, you need to use special solar filters.
Okay.
You can never, ever look at the sun with your bare naked eye because you could go blind.
Yeah.
They even had eclipse postage stamps, which I still have some.
Did you get them canceled that day?
You know, I do.
Yeah,
I do have first day covers, it's called.
Yeah, that's the philatelist thing to do, right?
Yeah. You got it. I have about a dozen or so of those.
I only have Elvis stamps, so not nearly as cool as the eclipse. Yeah.
This reminds me of COVID, but this was actually due to the huge amount of tourists that came into town to see the eclipse. They wiped out the water in the grocery stores.
Okay, well, at least they were staying hydrated.
Yeah. The local newspaper went crazy on the eclipse. Each day you can see countdown, the eclipse, 8 days, countdown, eclipse, 7 days. Every day was eclipse in the newspaper. This is the morning of the eclipse. I watched the eclipse with our group, a small group, outside of a little medical center, a little hospital outside of town from Casper, Wyoming. We got there about 5 in the morning because I wanted to get the spot that I wanted, that I had checked out the night before or the day before. So my wife catching some sleep. It was very cold because we're in Wyoming, even though it was in August.
So what were the what made this a prime spot for you?
It's called the center line, and the closer you are to the exact center of the Earth's shadow on the moon, the longer the eclipse is.
Of course. Okay, cool.
So this was about 2.5 minutes where I was near the outskirts. It would have lasted like 5 seconds.
Oh, okay.
So morning, the sun finally rose on eclipse day. And lo and behold, it was a big crowded scene compared to 5 hours earlier when I got there.
Yeah, you staked it out, and then these Johnny-come-latelys show up.
Yep, which is why I got there at 5 in the morning.
Nothing personal, John. That wasn't an implication about you.
This guy was neat. He had a hat that had an umbrella attached to it. It was like an umbrella hat. See, he's not holding, or is he? No, he's not holding it. No. He's not holding it. This is his name. That's his name tag. Yeah. All kinds of equipment, telescopes, binoculars, cameras. This is my wife and myself and my camera setup, one of my camera setups. yours truly with my eclipse glasses. And you can see also I had eclipse binoculars with special solar filters on the objective lenses.
See, is that something that you could add to a pair of regular
Yeah.
binoculars?
Yeah, this whole silver, well, my cursor just disappeared. The whole silver ring around the binoculars is added.
Okay, cool.
Yeah, that's separate. There you go. And
now, were you wearing sunscreen, Bruce?
Yes, I was.
Okay, good.
Yes, I was. Picture of my wife.
Hey, girl.
We'll go through that. Now, this is a phenomenon in solar eclipses. Every hole in this colander acts as a pinhole camera.
So cool.
And you can see the partially eclipsed sun in every hole.
I did that.
That's so great.
It's pretty cool.
Every single hole.
It's low tech right there.
Very low tech, but it's pretty cool.
It is.
If you don't have any solar filters, you can still watch the partial phases of the eclipse with a pinhole and a piece of paper.
Yeah, I think that's how I did the one that was in like 1984 or something. It was a partial eclipse, but we still got to see it that way.
Yeah. Now this, I always say, because still use this colander to cook with. This colander has been to Australia, Mexico, Wyoming, has seen 5 total eclipses.
It's hilarious. That's amazing. And so they never question you when you travel, like, sir, what is this colander for?
No, I pack it in my suitcase. That's checked. This is a close-up. You can see the slivers, the partially eclipsed sun. Now, the next one is something I had never seen before. Not this one, coming up.
That's still stunning.
Yeah. How about that?
The sink drain?
The sink drain, the people beside us brought it from their hotel room to see if it would work. And sure enough, you have the eclipse sun, especially in the smaller holes.
That's awesome.
Since this was a hospital, they used surgical caps to cover the lights because, of course, when it gets dark during an eclipse, the lights come on.
Yes. I wondered about that when you were sitting outside. Yeah.
So they actually used surgical scrubs, and my wife and I both worked in the hospital, so it was kind of neat to see the equipment that they used. Again, there's my camera setup. You can see the same silver solar filter on the end of my camera like I had on the binoculars.
Is that a weight holding it down to secure it?
Yeah, that's a dumbbell.
That's what I thought it was.
Yeah, that's a 20-pound dumbbell just to add stability to the tripod.
I was like, wow, or do you just like work out to be able to lift up all that equipment?
Yeah, I was working out while we were watching the eclipse. Couldn't get away. Couldn't go to the gym that day, so I took it with me. Okay, the eclipse is starting. Now is when it gets spooky. You can see you can see some sunspots, and just a little bite of the moon is taking out from the sun. This is actually the moon shadow, and it'll become more evident in later pictures. This is actually the moon moving in front of the sun. It's hard to imagine, but when I show this one little video, you can picture it. And you see it's around. That's one of the reasons how they initially said that the Earth and the moon were round, because the shadow of the moon is round. Now it's getting close. At this point during an eclipse, it's starting to get cool. Temperature drops about 10 degrees, and it gets dark.
Like the birds stop chirping. They think that it's nighttime.
That's right. Now it doesn't get pitch black, but it gets like right at this point, it gets like an eerie, surrealistic light. It looks just surrealistic, like it's not real.
Yeah.
So this is a diamond ring, and I took all these pictures, by the way.
Very nice.
This is called the diamond ring, where just one little speck of sunlight is getting through one of the valleys in a mountain on the moon.
That's what
And then this is, here's a prominence right here you can see.
Yeah, I was just going to say, you can see those, the little prominence around it too. Wow.
Here's totality. Here, this is why people travel for 50,000 miles, not that far, 25,000 miles to see the eclipse.
To see the total eclipse of the sun. Yeah, I think there's a song about that. So, wow.
So total eclipse of the sun.
And at this point, remember I was saying that the sun is producing energy every second.
Yeah,
which travels up from the core through the different layers of the sun and outside. And this is what escapes into space and travels out to the edge of our solar system. This is the beginnings of it. And when I think of it in those terms, it's pretty awesome. Actually, the corona, the surface of the sun is only a mere, 7,000 or so degrees Fahrenheit. Whereas the corona, and they've been studying this for some time to figure out exactly what happens, but the corona, all of a sudden, it heats up to millions of degrees.
Yeah. And this actually is Venus right here. Because you see the planets and the stars that are actually out there during the daytime that you don't see because of the sunlight.
So the moon looks pretty round when it's...
Yeah, here you can actually picture the moon. I'll show this again, I think. Oh, I can't. And you'll see the moon move off the other side. That's the other diamond ring. And here's the moon. You can actually picture the moon moving off the face of the sun. And then it got cloudy right at the end. I wonder, let me see if I can play this over again. That's the first diamond ring. Totality. Okay, here it started. So the moon is covering up the sun. It covers the sun for about this time was 2.5 minutes, and then it moves off the opposite side of the sun.
And you were just still shotting this? You weren't doing a video and taking stills later?
What this was I put all my pictures together and animated them.
Okay.
So basically, this is like 20 pictures or 25 pictures. Every 10 minutes, I took a picture, and then I put them all together and made like the olden days how they made the cartoons.
It's like a flip book.
A flip book.
Yep.
Now this, I'll show part of this. This is an actual movie that I did make. It should start in a minute. And my microphone didn't work. I'm gonna start about right here. You can see the sky getting dark on the right-hand side of the screen. That is actually the shadow of the moon coming. It's off in the distance. So you can see that the moon is still, the sun is still full. You can see it getting darker from the right right-hand side.
So this is real time, right? Yeah.
This is real time. Yeah, this is real time.
What do plants do that are affected by the sun? Do they like curl up for a little while this happens, or?
If you had a plant like some cactus that flowers, okay, you see the sun dimming now.
Yeah.
The sun's starting to dim. It's dimming. It's dimming. That's the corona. It's total. And you can see how the sky got dark.
Yeah, it's like you're seeing morning all over again.
Yeah. And if you look around the horizon, it's what they call a phenomenon of a 360-degree sunrise. Because all around you, the horizon, it's daylight.
Oh, right.
You see the sunrise, the orange color all the way around, 360 degrees. It's a real unique experience. The one thing about an eclipse, it's totally absorbing. It is an experience. It's emotional. Some people cry. Some people scream. Some people clap. It's a full, it's a 4D experience. It's not just like seeing this. This is the closest you can get to it without seeing it in person.
Bruce and
actually watch it happen.
Bruce and I were at a really long total eclipse down in Baja, California. I think it was 1981, was it?
91.
91. And it wasn't as evident here in the upper United States in the 2017, but down there in La Paz, when the eclipse begins and it starts to get dark and colder, you can actually see the birds think that nighttime is coming early.
They need to be
northwest of San Antonio, so we will be like right near the center line.
Yeah, out in the hill country there. That's where I grew up. So I'm like, far out. Maybe I have to go visit some family.
Yeah, go visit family. This is an experience. This is a chance to not have to go to a foreign country, not have to, spend $10,000 or $20,000 to get there. But you can take a few days drive to Texas and see a total eclipse
of the heart.
And then, as you can see, it comes up through the south and it goes through the northern parts of Ohio, Pennsylvania, New York, Massachusetts,
Rochester, yeah,
the East Coast. Now, here's some times and cities, and this is April 8th.
Okay.
Let me get that from you so I can share
2024. So it's a few years off. You can still plan for it. I got my reservations already. Hotel reservations. Here you can see the cities for the totality. Little Rock, Arkansas. Carbondale, Illinois is the center, which is unique because that was the center, the longest eclipse of the last one.
Paducah, Kentucky.
Last one in Wyoming was Carbondale, Illinois, too.
Wow. It'll be interesting to see if everybody goes as crazy for it across the country as they did when you were in Casper.
Yeah, I think they will. So, in closing, see you in 2024. Hopefully sooner.
Get your reservations now, ladies and gentlemen.
Yeah. Those of you.
So awesome. So awesome. Wow. Who feels like they have learned an awful lot today? Oh my gosh. I don't know about you guys, but wow. These guys are so full of knowledge and passion, and we are so fortunate that they are willing to share it with us at a at our star parties and here in virtual version of the Coachella Valley Wildflower Festival. You can just, amateur means for the love of it, and you really feel it when you meet guys like John and Bruce here tonight. So, ladies and gentlemen, as you know, this was our fourth Coachella Valley Wildflower Festival. Wildflower Wednesday was brought to you by the City of Palm Desert, the Agua Caliente Band of Cahuilla Indians, and Friends of the Desert Mountains, who put on the entire Wildflower Festival. This year, 2021 was virtual, is virtual. We still have things going on. You can still participate, and we hope that you will. If you want to know anything more about what Friends of the Desert Mountains do, please visit us at desertmountains.org and get a feel for everything we've got going on. There are volunteer opportunities more and more opening up as our Riverside County and our Coachella Valley open up. More opportunities for everybody to really participate. Look forward to something we've got coming up on Earth Day. If you really want to get your hands dirty, well, we got an opportunity for you. Ladies and gentlemen, this has been Wildflower Wednesday. Next Wednesday, we will be talking about the winners of our silent auction, the winners of our Valley Wide Youth Art Contest. We're going to have a video of all the entries. We sent out over 400 packages for this. So there could be an amazing amount. It is going to be so hard for our judges to come together. And we're so grateful for our friends at the YMCA and the Desert Recreation District who have helped call all of this together. We've got friends out at the Mecca Library. I mean, we reached far and wide, ladies and gentlemen, to bring you the best up and coming youth art. And it's all based on the inspiration they have from the nature they see when they are outside in our beautiful desert here in the Coachella Valley. And of course, the Santa Rosa and San Jacinto Mountains National Monument, our ride or die. All right, I am Karen. This has been Wildflower Wednesdays. And